Section 1.2, Points, Lines, and Planes. The objective for today is to understand basic terms and postulates of geometry. We're going to start with some definitions. You might want to write these down. We do have vocab tests on the definitions, so eventually there'll be a matching or fill-in-the-blank type quiz or test. Geometry is a mathematical system built on accepted facts, basic terms, and definitions. So we're going to start with a few undefined terms. These are the ones that are the building blocks of every other definition that we have. They're a little bit sketchy as far as why they're undefined, and I'll explain that in a second. Undefined terms cannot be defined, but are ideas that are used to build the definitions of all other figures in geometry. A point is a location and has no size. Well, if it's a location but doesn't have any size, how do we know where it is? So the part that's really the non-definitional part is we have to use some symbol of some sort to identify that it's a point. So most people have a picture in their head. Let me change colors here. A picture in their head that this is a point, and that's what we're going to do too. So we're going to represent a point by a dot, and we're going to name it using a capital letter such as A. So here is a point A. That's how you represent it. So not a small letter, you're going to use a capital letter. The next undefined term is a line. It's a straight path that extends in two opposite directions without end and has no thickness. This will contain infinitely many points. You can name a line using any 2 points, and we'll use capital letters there as well. So here's a picture of a line. It has the arrows on either side. The arrow means that it's going to keep on going forever, even though we're not going to run this line right off the page on either side. I'm going to call the first point A, the second point B. Notice when we're defining this, that has a point A and a point B, so it uses the definition that we've already talked about as far as a point goes. Here's how you label it, and here's how you represent it as far as names. Another thing that we can do is name it using a small cursive letter. So here's the 3 ways that we can represent this line. We can say line L. We can say line AB using the symbol above it, or we could switch the 2 letters and say line BA. So those are the 3 ways that you could name this line. You don't have to name all 3 unless they ask you to. Just pick one. The other thing that you might see is sometimes they leave this one out. If so, then you would only have line AB or line BA. Okay, so they don't always give you that little cursive letter that is next to it. That's the only way that you can name a line with a single letter. The third one, a plane, is a flat surface that extends without end and has no thickness. It contains infinitely many lines. Usually they'll make a plane into a parallelogram. The parallelogram keeps on going in all directions, even though we need a symbol for it, so the symbol needs to stop somewhere. So with this one, sometimes they will have a single letter in one of the corners. You could name this one with a plain P. You could name it with the word plane. You could use a small parallelogram. Oops, that looks like a rectangle. Just a minute. Make it a little bit slanty. If you use the symbol, make sure it looks like a parallelogram, not like a rectangle, because I will be picky about that. Let's say we have 3 points here. As long as the 3 points are non-collinear, you can name it with those 3 letters in any order. So one example would be plane ABC. Another example would be plane CAB. You could use CBA, you could do BAC, you could do BCA. All of those are equally correct. The back of the book will probably do 1 or 2, but there are more answers. A plane contains infinitely many lines. I don't have any lines drawn on here. We could draw lines through BC as long as there's 2 points. You can have a line going through there. I think that's all about planes. These three terms build on themselves. They form a building block to the next term. So like I said before, a point is used in the description of a line, and a line is used to describe a plane. The next two definitions are collinear and coplanar. Collinear means points that lie on the same line. So here's an example of this one. So in my picture, I have a line ABC. To name it, we use two of them. I would say line AB or line BC or line CA. You could do any two letters in any order. They represent the same line. The collinear ones are the ones that are on the same line. So the collinear points would be points A, comma, B, comma, C. The reason I didn't say D on here is because D isn't on the same line, so it is non-collinear. So point D, I'm going to put a parenthesis and put non-collinear. Okay, so the points that are collinear are all on the same line. Non-collinear would be off the line. When you're looking at a coplanar set of points, all points that are in the same plane. So let's call this plane P, and I'm going to draw that same picture that I had on the other example. Points A, B, C are all coplanar points. We'll have an example of a non-coplanar point in the next example. All right, so look at your textbook, problem 1, page 12. I have a sketch of this one. There's kind of a lot going on here, and we're going to go through how you represent lines, how many answers will you have, that sort of thing. So, first question, what are two other ways to name line QT? So let's locate QT. You'll notice that it's the line that's sticking up straight off of that parallelogram. Notice how there's dotted lines below. The ones below, the dotted line means the point is coming in. Like if I have a piece of paper laying on the table and I have my pencil going straight up from the table, but it goes through it. The dotted lines are the ones that you can't see right away. So they usually do a dotted version, and then once you can see them again, I should have drawn this in there. Once you can see them again, they do a solid line. So solid lines are seen like all the time. Dotted, they are not seen for a short time. Sometimes not seen forever, but most of the time, that's kind of how you can tell, is it on the page, is it off the page? So the solid line is that light blue one that's on the page. That is on the plane. The one that is part solid and part dotted is not necessarily all on that plane. So two other ways to name line QT. So I'm going to say, switch the letters. I'm going to say TQ. With the line symbol. Don't forget the symbol. I could say QN. I could switch those letters as well. Or I'm going to do three ways. I'll do three. Or I could say line M and use that small letter. Most of the time other books will use cursive letters, but here they just use a small letter. What are two other ways to name plane P? Well, they use this little letter in the corner to signify it's a plane. That's the only time you can use a single letter, excuse me. Two other ways would be to pick three non-collinear points. Remember, you're looking for a triangular spot, and you're looking to name the points that are on the plane, not the ones that are off. So on this one, I'm going to put a little note. Can't use point T, point N, or the small m. Okay, so you can't use any of those because those are not on the plane. So the ones that are on the plane are R, Q, S, and V, and we can do any 3 of those except for the ones that are in a line. So I'm going to name 3 that are forming a triangle. So I'm going to say plane RQV. Another one would be plane SQV. Basically, you can do any of those in any order. You have to include the V because that's the part that will make it into a triangle rather than a line. You can't have a line and a plane that mean the same thing. Otherwise, we would be totally confused. So if they're in a same line, it's a line. If they're not in the same line and kind of form a triangle, that's what you're looking for, then it's a plane. What are the names of 3 collinear points? Those are the ones that are in a line. We could do points R, Q, and S. And we could also say points T, Q, and N. And those are in a line as well. What are the names of 4 coplanar points? We cannot use T, N, or M, but the points we can use would be R, Q, S, and V. Okay, so those are 4 coplanar points. You cannot use the P in this one because that names the plane. How can you tell that the label P is naming a plane instead of a point? I've kind of talked a little bit about that. When you look at the picture, all of the points have that dot ahead of them. If it doesn't have a dot, it either indicates that it's the name of a line or the name of a plane. If it's not next to a line, that means it's in the corner. It's probably a plane. I'm going to say it doesn't have a dot next to it. And it is in a corner of the plane. Why is plane RQS not a valid name for the plane? Well, let's look at that again. Plane RQS, those are all collinear. They're in a line. I'm going to put they form a line. And put collinear. You could say they're collinear, they form a line. Either one of those would work. What points do lines L and M have in common? So we're going to look for the intersection. Line L and line M intersect at point Q, and you do need the symbol as well as the letter. A couple more terms. Space is the set of all points in 3 dimensions. A segment is a part of a line that consists of 2 endpoints and all the points in between them. A segment, if you take a line, and let's just put the points A, B on it, the segment is this part of it. Okay, and the way we name that is just this, AB with a segment symbol. There's no dots, there's no arrows, or we can say segment BA, either one of those. Array is part of a line that consists of one endpoint and all the points of the line on one side of the endpoint. So here they're talking about a line again. I'm going to put AB on here again. I should have made that a little longer. Let me do that again. So I'm taking that same line with AB on it. Okay, but this time it consists of one of the endpoints and all the points going one way. So here's one example. If I take this part of the picture, I would name this one Ray AB. Now, the one specific thing that you need here is the point needs to be listed first. You cannot name B first because that's not where this ray starts. It starts at A and keeps going to the right. The other thing we need to be sure of is even if the ray goes to the left, the symbol always goes to the right. So if I do this and make this my ray, oops, let's say, this one would be called ray BA. So even though it starts on the right and goes to the left, the symbol above it goes to the right. Opposite rays are two rays that share the same endpoint and form a line. So when I look at this one, I'm going to put another point on this one. I'm going to have an A, a C in the middle, and a B. So when I look at this one, they share the same endpoint, so, and they form a line. So I'm going to say two opposite rays would be ray CA and ray CB. Okay, so here's their common point. One of the rays goes from that point to the right. The other ray goes from that point to the left. Notice my symbols both go to the right. And what happens is these points cannot overlap, these rays. So I'm going to say they can't overlap except for the point that they contain. Okay, so they can't contain, like, I couldn't say ray BC and ray CA, because first of all, they're going in the same direction. They have to be opposite. The only point that they can have in common is the point that they share. No points are skipped. See problem 2 on page 13. So I have a line with the points D, E, and F on it. What are the names of the segments in the figure above? So if we're going to do all of them, I'm going to start with D. Remember, segments are 2 points, and it doesn't have the line symbol above it. So I'm going to start with D. So I'm going to say DE. I could say EF. I could say FE. I could say ED. I could say DF. And I could say FD. Now, these are really the same. I'm going to underline them. These two are exactly the same. You do not have to say them both. Okay, these two, oops, that didn't change color, just a minute. Those two are exactly the same. You do not have to say them both. And these two are exactly the same. You do not have to say them both. So when you're looking at it, you really have 3 different segments. It's just how are you going to name them? What are the names of the rays in the figure? So remember, rays have 2 letters, and the points need to start somewhere and go only in one direction. So I'm going to say ray DE. I'm going to say ray DF, so I'm only going to the right so far. We could also have ray EF. That pretty much takes care of all the ones going to the right. The ones going to the left will be different, so I need more names this time. I'm going to say ray FE. And now when I said 2 rays were the same on the last one, or 2 segments were the same, the rays do not work like that. You have to have them both because one goes one way, the other goes the other. I'm going to say ray FE, I'm going to say ray FD, and I'm going to say ray ED. And on this one, you would have to have all of those if it asked you for all of them. If it asked you for just 2, then you could name 2. Which of the rays in part B are opposite rays? Okay, well, I'm going to look at this and I'm going to say ray EF. The E is in the middle, so I'm going to kind of focus on this point right here. And I'm going to say EF, so that's the one going to the right, and ED would be the one going to the left. Remember, they do have a common point and there's no overlap. There's no spaces either. Do the names segment DE and segment ED represent different segments? No, they do not. Segment DE and segment ED are exactly the same. If it said ray DE and ray ED, then it would be different. Can the 3 points shown be on the line be used to name a plane? No, they are collinear. A plane has to have non-collinear points. How are the segments DE, EF, and DF related to each other? Segment DE, segment EF, and segment DF they're on the same line. And postulates are axioms. We are now on page 13. A postulate is an accepted statement of fact. It is used to prove general concepts in geometry. So this book will use postulate rather than axiom. So even though you'll have to know both definitions for this first test, postulate is the one that the book generally uses. What I want you to do is make sure that you read the part in yellow. You also read the part in green. I want you to keep a small notebook with the lists of these postulates and theorems in there. I want it to be separate from your notes. It's easiest if you just have them in a separate notebook, because then you won't mix up notes and postulates and what can you have and what can you not have on the test. You will be able to use this notebook on all tests and quizzes throughout the whole entire year, so do not lose it. Some people put them on loose leaf paper. That's perfect. Some people buy one of those really cheap quarter-cent notebooks and keep them in there. Some people put them in a different section in their notebook. I would like to have it in something that you can keep separate. Many people do their notes and their postulates mixed together, and I'm not going to allow you to do that this year. It's too easy to look and cheat on things, and I don't want you to do that. And I don't want you to get caught, because then you can't use them on tests and quizzes. Please keep track of the notebook. Always bring it to class with you. Don't say, oh, do we have postulates today? Let me go get it. Nope. Bring it to class with you. You need it every single day. The more you look at them, the more you know them, the easier the class will be. If you don't bring it to class, you do not get to go get it. You will not be able to use it on the test, quiz, or assignment as needed for that day. You would bring it the next day, so you could use it then. This postulate and theorem notebook will not have notes in it. Only the postulates and theorems that I tell you that you can have in it, you can have in there. So starting today, if you don't have a separate notebook, you may get a separate notebook and then write them there. Keep them together. Don't do anything extra. Generally, you get to do the words only. There are a few that I allow you to do the picture, but not all of them. So generally, it's words only, and I will have them in the notes so you know exactly what you need to write. So postulate 1.1, through any 2 points, there is exactly one line. Postulate 1.2, if two distinct lines intersect, then they intersect in exactly 1 point. Postulate 1.3, if two distinct planes intersect, then they intersect in exactly one line. And here's example 3 on page 14. You can look at the picture there. It does make sense when you look at the picture. I don't allow you to have the pictures because generally you'll have different pictures in the assignments and it'll be harder to tell what's what. So just get used to using the words only. So we have a cube. You can ignore these in here. I couldn't get them deleted. I just copied and pasted from online. So just ignore those. Each surface of the box above represents part, not party, of a plane. What is the intersection of plane ADC and plane BFG? So here's where I suggest if you have different colored pens and you have something that you're confused about how they intersect, where they intersect, what they intersect in, using different colored pens or markers, will definitely help. So plane ADC, as you can see, ADC are on the top of the box. That's this plane. Notice that plane BFG is the right side of the box. Those are the only two things that I'm looking at. So if I actually shade them entirely in, notice that this, oh, let me change colors because you can't even see that. This part right here is the only part that they intersect in. You have to name that. Is it a segment? Is it a line? What is it? So when you're looking at this one, remember that planes go in all directions. So it looks like it's a segment, but it actually intersects in a line. Two planes intersect in a line. And when you're looking at it up here, if two distinct planes intersect, they intersect in exactly one line. So it is not a segment, it is a line because of that theorem. So we're going to say line BC. What are two planes that do not share any points in common? So I'm going to erase my lines here. I would say planes that are on opposite sides of the box. So I'm going to say plane, I'm going to say the left of this box and the right side of the box. Plane ABF and plane DCG. So when I looked at that, I said plane ABF, and I named them in the same order on the right side of the box, plane DCG, because I feel like if you do in the same order, it's easier to say. However, remember plane ABF, plane BFE, plane FEA, those are all the same plane. So basically what you're looking at is you need to use opposite sides of the box so that the letters are all different. Postulate 1.4, through any three non-collinear points, there is exactly one plane. And here's our last example. See page 15, it's problem 4. We have a rectangular prism. We'll learn more about that later. What other points in the same plane as points N, P, and Q? That question doesn't make sense. Let me see if I missed something. What plane contains, oh, I typed it wrong. What plane contains, I don't know what I was looking at when I typed this. What plane contains points N, P, and Q? So point N, point P, point Q. So what plane contains points N, P, and Q? Well, the easiest way to say this is plane N, P, Q. Why not use those same letters? Another one would be plane RNP, plane RQP, plane PQR, plane PNR. Any of those would work as long as you're naming something that's on the bottom of this box right here. So any three letters on the bottom of the box will work. I think it's the easiest to use the three that are given, but there are more answers that work. What other point is in the same, this is probably something, what plane contains points J, M, and Q? Again, I don't know what I was looking at. What plane contains J, M, and Q. So J, M, Q. Okay, now this one, I'm going to erase the purple and these points because this one is a little bit confusing. I'm going to do this one in yellow. So plane J. Oh, shoot. Sorry. That really took off. Went back to the beginning. Here we go. Plane J. M. Q. Now, when you're looking at that, you're thinking, well, that's not even an edge of the box. What you need to realize is that there's not only planes on the edges of a rectangular prism, there's also planes that can go like and be used as the diagonal. So with this one, the plane you're actually looking at is this one. And I'm going to kind of shade it in so you can see it a little better. So as long as there's 3 points, it can form a plane. So I'm going to say for this one, I'm going to say yellow, plane J, M, oops, no comma, J, M, Q. You could have any 3 letters on that diagonal yellow plane that I just drew in there. MJP, PJM, MQP, QPJ, any order there is fine. What lines contain 2 of the 4 points J, K, L, and M? So now I'm going to erase my yellow plane. Okay, I'm going to switch colors. So we have J, K, L, M. Okay, so what was the question again? What lines contain 2 of the 4 points? 2 of the 4 points. We could say line JM. And there's quite a few of these. Line JM. We could say line KL. And basically you could go around the box and do any of those. And remember, line KL and line LK are the same. Line JM and line MJ are the same. We could have line LM. We could also have KJ. So you could have 4 other options. I'm just going to write the 4. What is the intersection of plane JMQP? JMQP, sorry, it went again. Every time my keyboard pops up, it goes way back to the beginning. Sorry. What is the intersection of plane JMQP? JMQP and plane JKLM. Okay, so JKLM is the top. And the other one is the diagonal. Like that. So if you look at, and I should probably do that in a different color. Where they cross each other is line JM. Oops, I don't need the symbol since I have the word. So when you're looking at that one, you can have a double arrowed line above it. You can have the word, but just be careful. Use those postulates so that you know exactly what you're doing. When you're looking at the intersection of planes, you are looking at this postulate right here. The intersection of planes was up here. If two planes intersect, they intersect in exactly one line, so you would have to name a line. If two lines intersect, they have exactly one point in them. So every single thing that you do in geometry goes back to these postulates, which makes them very, very important. The more you look at them, the more you know them, and the less you have to look at them later. So please be aware that you should be using them, not just writing them down and never looking at them again.